Good evening, children. Welcome to my workshop. Today I'm going to be telling you my latest project. I'll try and make it as short as possible because I know the attention span of some of my family and friends, so it will be quite short. But remember, kids, every day is a school day, so we've got to learn something here. So, we're in the workshop. I am suitably dressed for engineering. Forgotten one thing. That's better. Okay. Today I'm going to tell you about my additions or improvements to my milling machine. What is a milling machine, you ask? It's a machine that mills. Basically, it makes flat things flatter. Unlike a lathe, which makes round things rounder. So, I have two. I have a milling machine and a lathe. Now, little history on these machines. I bought these over 30 years ago with the intention that in my retirement I'll be able to make stuff. And guess what? I'm in retirement and I'm making stuff. Brilliant. I've carted these from house to house, trying to look after them, and finally we've settled and I've got a newfound interest in the machines. So, a milling machine. It mills flat stuff. But what have I been working on with this lockdown period, Powerfeed. Powerfeed. You don't know what Powerfeed is, do you? No. Normally, with a lathe, milling machine, you twiddle these dials here, and it moves the part. Oh, that's a bit stiff there, that's it. It moves the part underneath the milling head. So this is a cutter, right? You can put in drills, you can slot drills, all sorts of stuff. At the moment, I've got this, I don't know what it's called really, it's some sort of cutter. So I can twiddle it down there. So that moves the y-axis. Okay? Y-axis, x-axis, z-axis, 3 axes. Right? We haven't got the time displacement machine, so I can't do a 4 axes. Now, you can see the problem. If I want to make something, I have to stand here and twiddle. So see if I turn it on, okay? Go down, go back. So just go, so it's just touching. The top of that, I'm going to turn that down like that. Slowly move it across. Okay, you can see the problem, can't you? You see, little rubbish finish there, but anyway, not worry about that. So you can see the problem. I'm going to be studying all day. I've got better things to do. So, Powerfeed. Here we go. Here's the little baby. Okay, got that? And I'll give you 3 guesses as to what's in it. Yeah, it's a Raspberry Pi. The good old Raspberry Pi. For those who have not heard of the Raspberry Pi, no, it's not. You don't put fresh cream on it and eat it. It's a computer. It's a very powerful computer. Anyway, I won't go into too much detail. I'll just demonstrate it. So what we've got, I'll just make sure that's out of the way. We've got normal power feed, so I can go slow, speed up. Okay. Go a little bit faster. Oh yeah, that's as fast as it'll go. I did run into a little problem. If you go too fast with a stepper motor, it locks up and it doesn't sound too good. And it destroys the couplings. So, say if we come over here, so here's a coupling here. This is the remains of the last coupling that just sheared off. So a lot of torque going through an aluminium coupling. So I made my own. I made my own on the lathe. Brilliant. So that's the Powerfeed bit. We can do fancy things like I've moved it about, right? I can actually return to 0 wherever 0 was. Wherever I set 0, I don't know where I set it. So there's a little bit of intelligence going on. It's not just press a button and it moves. There we go. And it's at where it's 0, and I can just like tweak it. See this little display here? I can just tweak it down to the start. Now what we can do, so Powerfeed to the start. What I can do, I can reset that to 0. I can then bring that down. What I need to do, because I've moved the position now, I need to do a slight skimming cut. Just so it's touching it. There we go. Set up the speed cutter. That's good. And so I'm going to make it go nice and slow. So that's it. It's doing what I should be doing. The motor. Eventually that will hit the piece and it'll start cutting. There we go. Taking a very fine cut. So I don't need any coolant, going very slow, just to show you what's going on. And with the magic of time displacement, I'm going to fast forward it. And we're nearly done. Speed up a little bit. Obviously don't go too fast because you'll have a rubbish finish. Right, I'm actually going to it's finished. Say that. So okay. And there we have it. Didn't quite go to the end, I stopped it. So there you go. So not a very good finish. The cutter is probably a bit old. What you then need to do is take some emery paper and polish that nicely. But the main thing is, it's flat. Okay. So there you have it for the Powerfeed. Now, I have added another little addition to the milling machine. Now if you notice, with conventional milling machines, DIY milling machines, like the whole hobbyist, it's all twiddling dials. And you've got these little divisions on here. So you've got these dial indicators on here. So you probably won't be able to see that. I can't hardly see it. And to move it that way, like 1 mil or 0.1 of a mil or 10 microns, you've got to like read this busy and then oh, it's just so tiny, and then it slips and everything, and you forget where you are. So this is my next improvement, and I'm really excited about this because I've added to this machine digital readout. DRO. Okay? A DRO, digital readout. Now this is a beauty. Alright, it's not beauty, it's Chinese. What this does, it's got transducers on the cross line, on the slides, on the table. Oh, look at that. I'm twiddling that dial, the y-axis dial. And I can get it to wherever 0 is. I can also bring in the power feed. And then x-axis, because the power feed is on the x-axis. Now there is an inherent problem with this system. It's called backlash. So with any of these rotary dials, you twiddle a dial. So if I twiddle this dial here, well, I could twiddle this dial. I'm moving this dial and I'm not getting any movement there. Okay? And that's a common problem with mechanical machines with screw threads and stuff. Backlash. You've got a screw and a nut on it and it just slips a little. So, but the beauty of this is the transducers, or the linear scales, are actually on the table. So there's one here, and that's the y-axis. And then you've got the x-axis one under there. And they give you absolute precision of where that table is. So what that's saying there is where the table is. And you can do fancy things, you can zero it all out. Now at the moment, I've got X and Y. I've got to add Z. So I've got the transducer ready to put on. I'll wait till the weather gets a little bit back before I put on. Now, looking at this, looks pretty similar, doesn't it? We have display, LED displays, LED, buttons, knobs and stuff. I could have made this. In fact, I did. "30 years ago, I made one of these. It had the displays in. I had X, Y. Oh, funnily enough, look at that display. It's the one that came out of it." So, 30 years ago, I made one of these. Granted, it were a bit naff, because I didn't have these linear scales. But the basic principle were there. And I did actually have a power feed as well. Look, speed. Rabbit. It's called rapid, but it's supposed to be rapid, but I call it rabbit. NR Machining Centre. I'm really pleased with that. It's a shame that I've got no innards left, but I've stripped it all out. Done whatever. So I made one. But nowadays you can buy one from China, cheap as chips, and it does everything. And get the linear scales with it. It's beautiful. You can just do precision control. And we're down to 5 microns here. 5 microns. 0.00 5 of a millimetre. That's 0.005 of a millimetre. I don't know what the thickness of a human hair is, but I bet it's bigger than that. And the functions on here, I'm not going to even do 90% of them. So that's basically it. Z-axis to go on there. Now, what I'd love to do is make this into a CNC machine. Now, CNC, computer numerically controlled, is you load in a program and it just does it all by itself. But hey, I'm pushing my luck there a little bit. Let's just be happy with one axis, play with it, make some other bits and bobs. I don't know what I'm going to make next. Probably something from the lathe. And that's basically it. So, thanks for watching, and see you next time. Oh, wait a minute. Thanks to my lovely camera lady, it's Millie. She's not going to show you a picture of her face because she's in a dressing gown. But thank you very much, Millie, and I'll see you later.